we're going to go to the cutter and let's see if there's any data that's different. Stick that to the left. Okay, our cutter diameter is 1/2 inch. Length of cut. Okay, so we got 3 flutes, 1/2 inch diameter, 1/2 inch shaft, so a 3 inch overall. Pretty close to the same thing. We're going to change the length of the below holder to be 1.5 inches. It's about half the cutter hanging out. We're going to leave the shoulder and flute length alone. And we're going to shaft, we're going to leave that default, looks okay. Holder. Expand this holder standard taper blank. We're going to pick a CAT 40 or CT 40 blank number 2. So we're going to select that holder. Then we go to our cutting data. Let's go see what our Harvey tool information says for cutting data. Yeah, we're going to look at our cutters. What we have here. Okay, so we're going to look for our surface footage, and it looks like they do it by their neck diameter. So if we look at our Harvey tool, the neck diameter is 251 thousandths. So if we look at 251 thousandths for our neck diameter, we're probably looking at this one here. It's at 250. And they're saying for aluminum alloys we should use 750 surface feet per minute with a chip load of this here, 2007/10. I copy the value there and see if we can carry that over. So our surface feed per minute should be 750. Okay, so they want us to go a little bit faster in this material. And our cutting feed rate is going to be chip per tooth. Paste what Harvey Tools got in there. And we got about 47 inches a minute. So I don't like these oddball numbers, so where you have a lot of decimal points when it comes to feed rates. So I'm just going to go ahead and set this to 47. And that'll go in suit there. It kind of ignores the feed per tooth. It's pretty close. Our ramp feed rate, typically I go about half. So let's go half of 47 would be 23.5. So let's just do 23. Plunge rate, 23. Okay, and then on post processor, we're going to set this up as tool 19. Offset 19, and it is a live tool because it's spent. Let's hit accept. We're going to close the library, and then we're going to do a 2D contour. We're going to select the tool we just made from the Sierra 1 library, tool 19. Select that. There's our cutter. The default feeds and speeds should be what we put in there. Okay, our geometry, we're going to select the bottom root edge of our dovetail. Make sure your arrows are on the outside of the part. We're going to go to the next tab, clear our heights. We're going to go from model top, not stock top. Okay, and we're going to go from the top height to our selected contour. Under passes, We're going to do wear compensation. Finished feed rate is going to be 47 inches a minute. We are going to do one roughing pass on its diameter. We're only going to do one pass, so that's pretty high. We don't want to be going almost the cutter diameter, so it's 0.5 times 0.8. We'll say our maximum step over is 400 thousandths. It only matters because when you're doing multiple steps, really. And we're going to do one depth. But now that we check the roughing passes and we're doing one, we got to go up to our step over here, which is set at 50 thousandths. We want to set that at 10 thousandths. Multi-axis, leave it alone. Go to the next tab. We're going to come in a sweep angle of 0 straight on. Our linear lead-in distance needs to be at least a half a cutter diameter. So we're going to go 0.26 for our lead-in. We're going to have no vertical lead-in radius. And let's see how this does. So in reality, there'll be a little radius, but it's calculating the tool to its theoretical sharp. All right, that's it. You have that tutorial that you can apply the machining principles to for any of these dovetails for the 5-axis system. Hope that's helpful. Catch you in the next one. Programming for the top. So we're going to go from design, and we're going to open our design window. We want to bring in the fixture that's on the UMC 750. Now I'm choosing not to bring in the whole machine. If you'd like to do that, you can. But it's more important to me, we have collision detection. So we have our file, and we have our two bodies that we can toggle on and off. So we can turn our stock on and off to make it visible or invisible. And then we can bring in our vise setup. Now I've uploaded a file. You should be able to upload it, and then you can bring it in as an assembly. It might come in a weird orientation. So we're going to move that so it looks in the same orientation as our model. We'll move it down below it. And we're going to select that location. Now it's going to by default ground this. We want to unground this from the parent. So we want this to move around, and there's a orange auxiliary plane I've created that's here. That is the plane in which the bottom of the part should interface with the fixture. Okay, so I'm going to hide that plane. So I've created a point that is 80 thousandths below the surface. It's a lot easier to do mates with this. We've left the jaws so that they can move back and forth once it's fixed to the model. So we're going to do a joint, and we're going to select this point I have here. And we're going to rotate to the bottom of the part, and we're going to make that joint to the middle bottom of this. And it should be a rigid joint, should work. And it positions it in the proper plane on center line of the fixture. Now I've left these so you can slide them back and forth for collision detection. If you choose to do a joint between them, you could, or you can just kind of position them in location so that you can see where it is. The important thing is that once you start doing machining, you don't mess with this model much. Okay, so there we have our fixture with our part in it. Looks like we're going to have plenty of side clearance to get the side holes. We have plenty of depth. If we choose to use a drill bit to go through, we can do that. There should be plenty of space there. Okay. we've done that. And you can always turn the image on and off so that you don't have to be looking at it unless you want to. Okay, make sure we've saved. And now we're going to go over to the manufacturer side. Okay, we're going to create a setup. Our first setup is going to machine this part pretty much like a 3-axis mill. So we're going to go setup, new setup. And we want to select what's our actual part. And select, and we're going to open our model bodies. And we're going to actually select the body of the model itself. Okay, now we're going to select our fixture. Select fixture, then we're going to select the model of the UMC 750 vise setup. And there's no need to select the fixture attachment point because we've done that through another method. Okay, and then we're going to go back to our stock, and we're going to set our stock as from solid, and then we're going to select our stock volume. Now remember, our volume's already machined down by 30 thousandths because we made our volume in the back. Okay. Now we're going to go back to setup, toggle back to the setup tab, and we're going to place where our origin is. And we're going to use what's called dynamic work offsets. We're not going to use model orientation. We're going to go X plane, which is going to be the top of our stock, and our X axis. Which that looks okay. That should be fine. We'll go ahead and select the edge that's in alignment with our X axis. Now our origin is a stock box point, and actually the one that it's already selected is good. This way we can do touch probe selection. We mount the part in there as long as it's roughly centered. Our dynamic work offsets will do the calculations to take it off rotation of center. So you can really choose anywhere you want, but if we're looking at how this vise system works, is it centers along what we see as the y-axis right now, and then visually you're going to center it in the x-axis. How I typically do that, if I'm going to just eyeball it, I draw an X between the two corners of the material, bring a sharp pointy tool down, and then have it line up with that little crosshair, and then you can tighten it. Now we have the probing. Everybody's stock's going to be slightly different size, so what we could do is program for center of block. Our stock tab should be good. We should have 2 inches, a width of 3 inches and 400 thousandths, and we've skimmed a 30 thousandths off of it to prepare it to go in this machine. So the stock height is at 970 thousandths. Under post-process, we're going to call this 0302. We're going to call this 302 2. Our first operation would be cutting the dovetail operation. So we're going to say op 2 UMC 750. And we are just going to go with work offset number 1 or 0 will give you the same result. And we're going to change this setup to op 2. We've created op 2. The first thing we're going to do, we're going to do a 2D face mill operation. And we're going to select the face mill, which is tool number 1, from the CRUMC aluminum tool library. We're going to pick up the face mill. I'm just going to leave the feeds and speeds at default. I am going to round this off at 50 inches a minute. And our plunge rate, oops, 50. Plunge rate we'll leave at 13, give us some reaction time. Okay, our geometry is the top of the block. On our heights, retract's going to be based off stock. We're going to feed from the stock top height, and we're going to cut to the top of the model. We're going to go to our passes. Pass direction, I think we want our pass to go along the x-axis. I think it's a 3-inch end mill, shell mill, so it should be able to clean this up in one pass. Pass extension, let's add a little bit more. Let's go to 1.75, let's give us some extra clearance. And we get a step over of 2 inches, which is fine. And we can go both ways. We're not going to do multiple depths on this, we're only taking a little bit off. And we should be able to leave all this at default, except for I hate vertical lead-ins, as you probably know by now. Let's hit OK. Alright, so we got our one pass with the face mill. It's really a 3-axis move. Next, we're going to move on to profiling the outside of our part so that we are clearing out all the extra material around it. And we are going to cut past just to make sure we get some clearance. So we're going to do a 2D contour, and we're going to switch to tool number 2 in our library, which should be a 1/2 inch end mill. Okay, let's round our cutting feeds off. We're going to go 40 inches a minute. And we can leave those other ramp and plunge rates as is. We're going to go to geometry, and we are going to select, we'll need to hide the stock, and we're going to select the bottom profile of our part. You could pick the top two, either way. Okay, and we're going to go to heights. And at this point, I think we can retract to model top, and we can cut from model top. And instead of selected contours, we're going to cut to the lowest of selected, which is the model bottom. Okay, we need to make sure we have the right thing selected as a model. And then I want to cut a little bit deeper. We're going to go negative 0.020. That way we just make sure we cut a little bit clearer. We're going to go to passes, and we're going to move to wear, so we can use wear compensation. Don't anticipate needing it on the outside of this. We're going to do roughing passes. The maximum step over, we're going to set it as 80% of the diameter of the cutter. So 0.5 times 8 gives us 400 thousandths. Okay, our smoothing deviation, we'll leave it at default. We're going to do run one step over. We are going to do multiple depths. Maximum roughing step down. Let's do. We're only cutting an inch, so let's do 1/2 inch steps, and we will do one finishing step down in Z. And that'll be at 8 thousandths. It'll in effect be really a spring pass for any cutter deflection. And we're going to finish it only at final depth because we can. It's this particular part, we've got plenty of end mill space. And we're going to use even step downs. We don't want to leave any stock. And what the heck, we'll turn on the smoothing deviation. We are going around these small radiuses that we want to output a nice point orientation for it. Then we're going to go to multi-axis. We're going to leave this at 3-axis machining. And then we're going to go to the linking tab. We want to check this box that says keep tool down. Otherwise it's going to pick up on every pass. And horizontal lead-in radius is fine. Linear lead-in distance. This needs to be a little bit longer. We're going to make that 0.6 we want, I'm sorry, 0.26, we want that to be a little bit longer than half the diameter of the cutter, and it allows the cutter comp to come in. We're going to put no vertical lead-in radius, and we'll have the lead-in lead-outs that are fine. And if we want to make sure it's cutting on the side that's facing us, we could put a preferred lead-in position up maybe here. Well, let's put it in the middle. Okay. And let's hit OK. Alright, so we've got our couple passes, and then we got our finished passes at the bottom. Looks good. Alright, now we want to do our drilling on this face.